So have some in the data exchange. So first let's open folder again. I've extracted everything to USD root. See, and I'm on my laptop, so I don't have the data exchange. Do I? No. So I have to download this as well. Setup.
Okay. I've got something for all of you. There is the AUUSD core specs, right? Which is a PDF that you can download from the AUUSD website. Since you're using Cursor, Michi, the PDF doesn't really help you too much, because even if you can open it in Cursor for your LLM, it's parsing the text and it's missing some of the crucial flowcharts that are in there. I therefore took the effort and converted the flowcharts into Mermaid charts, so I have an MD file of the AOUSD core specs, which I will drop here in the chat.
Yeah. I was just extracting the example files, you know, for the because you can download it here and then.
It doesn't let me pull anything in here, does it?
Did you?
It doesn't let me pull. Wait. It doesn't let me drop anything in the chat here.
Then maybe just if you share the link.
Yeah, I will make a link. Yeah.
Okay, so I've unzipped the data exchange here. And what's missing still? We have to activate the Python environment again. I do like Python scripts and activate. Now we have our right. So everybody on the same page again? So we can then come on. There we go. OBJ to USD Python. So we copy this. I maybe do it in the data exchange. Right. Okay.
So I shared the links. Shall I say a word or two before you start? Or are you almost there? Okay. Okay. Who's using an LM or Cursor or anything like this?
Not yet.
Yes.
What? Okay.
Not yet.
Okay, but if you do, it's important to avoid drift and give the LM a strong founding. There's several ways, but pointing it at documents is one way. And this AOUSD core spec is like the Bible from USD as it is right now. And therefore, to be able to point your LM at it is really nice, because then it will reduce hallucinations. Thing is, LLMs can't really read PDFs that well, And therefore, you have to provide it in an LM readable format, which is an MD format. And within MDs, you can define mermaid charts, which is like flow charts, which is text for them so they can totally understand it. So I provided this file. There's a warning in there in the beginning because I didn't check if the mermaid charts are correct. And there is like a small router in the beginning, which will help your LLM to get to the right section.
And could you maybe share your screen and show how you like integrate it? Because
Oh, yeah, okay.
maybe
Actually, in my case, I have a soul file, and then a skill file, and I define this in the skill file when I go to OpenUSD and Omniverse. There I say, please use this file. So it's not integrated in that way. It's I will share a link about skills and souls, okay?
yeah, maybe
This is probably better.
I somehow, oh, now I can open the chat as well.
Yeah, and I'll let you proceed now.
Yeah. And now we're opening the OpenUSD, and I've copy and pasted the source code, right? And so now it complains. Why would that be? It's missing main, right? Calling main, but we don't have a main yet. So let's see what we do about that.
The code block is missing.
Yes. And what have we here? A code block called main. Let's use that. Right. So what does it take? The arguments from the command line basically, and
There's the main.
Yeah, and it's basically just the process extracting information and transforming it to the stage, and then saving it again. Okay, so let's add the code here. Okay. We've got a main and doesn't complain anymore, but still complains. We need an extract and a transform. So let's look for that. Aha, we're calling two functions, extract and transform. And here we've got the extract. What does it do? Basically import the file using the assemp library, and yeah, basically creates a new stage, returns new stage. So far so good. Let's copy that. Okay, doesn't complain anymore about extract, complains about transform. So transform is just defining the function and do some output, but doesn't transform yet. So that here maybe transform, but no complaints. We have the definitions and stuff. Should be able to let that run. We will not execute the script yet, but we'll continue to build upon it throughout the rest of the exercise. Makes sense? Yeah. Now we have basically just the skeleton without, or just a little functionality. So, what do we do? What is data extraction? Is the website for you guys also so slow, or is it just my mobile connection?
It's not slow. Yeah.
Oh, okay. No, good. So yeah, we want to first get everything what we can get from the source from the original format, and yeah, transform like to get this into USD, right? Actually, output data looks like it did exactly, yeah. Oh yeah, we understand also the source format better if you just read it and write it as USD. Exactly. The transient data, I think we touched that last time as well. It basically says there that we not necessarily have to write everything to disk when we like work with a stage, but for debugging and just knowing what happens, it makes sometimes also sense to just write it out. That's what it says. Should consider that also make that information accessible, what you're doing while transforming, converting the data. Next. USD is about the collaboration, so we want to make it as easy as possible to like interact and collaborate with each other. So
there's also another thing that you can do. I briefly talked to Stefan Reinhardt about this yesterday, and Thomas was also there. So I asked Stefan with the ESG. So Stefan Reinhardt is from ESG, and they've got this virtual commissioning tool.
Virtual commissioning software.
Yeah. Yeah. And there's like a connector into Omniverse, and I was asking him, so when do I use this connector, and when do I use a pipeline to establish my digital twin inside Omniverse? And there's something interesting what you can actually do. If you have the governing body for your cut data, which is a PLM system, and this is governing your ESG, your virtual commissioning tool, and also governing anything that you import into Omniverse, then you can take the best of both worlds, because in the ESG will give you a rigged, it's not called rigged, how do you call it here, Michi?
That's basically actually I was involved in this demo. I can quickly show. It's basically a virtual commissioning tool.
Yeah.
Kit. So you have the virtual or real PLC, which controls the processes. I can quickly show you a little video about it. That's quite nice.
The cool thing. Yeah. Okay. Go ahead.
That's the demo basically. You see, it contains 3 different data sources. So one is the real environment, the real PLC, right? The control unit with its code, and this is what you see now as a simulation. So the workers are like the worker movements and everything is pre-simulated, and it communicates with signals, OPC or A in this case, so from IoT to bring everything together. And so it's also like an example of bringing together the output of in this case EMA Work Designer, which is an ergonomics tool, which is its own format. They have like this prefabricated simulation, and you have to add like an additional layer which does the signal handling, right, from the IoT. And so this is basically reading the original format of those guys. They don't have any like idea or sense of like a PLC involved, because they do like the human simulation, right? But with that, you can just use USD to add this additional information and create like this, complex scenario, right? So that's an example. That's a good hint, Jan.
Yeah, and in addition,
that,
there's something else. So let's say that you have your ESG and you make the direct link or the connector. So all the data which is running in the ESG is being converted into Omniverse in real time. And you have all this data now stored in Omniverse, but it's how do you make sure that when you change when the machinery or something from the CAD system, small things are being changed, that this is still being updated in the stuff that you actually got from another system. And this is where you can use the IDs or the namespace or whatever you have as an identifier to swap out this this geometry underneath, which is with the layering system. So you can do this. And the cool thing is that this data that you get from ESG is like rigged, meaning that the joints are defined and everything, which is not necessarily the case when you get the stuff out of your CAD system.
Right. And the basis for this is like a digital twin asset pipeline. So basically, you know, if one thing changes, it gets either it's a layer, already a sublayer from something else, or it triggers like a process which adapts and transforms it. Like and this is again this part, right? That's something in the pipeline which then loads maybe the EMA simulation and adds another layer to it, or also transforms it as we read here. Yeah, that's a good example. Thank you, for this excursion.
Yeah.
And so basically what all this takes into account is texture meta material conversion. That's especially for design backgrounds. Meta information, as you said, the ID of the elements, for example, or like links to catalogs, or like SAP source information, whatnot. Basically, the idea is to just load what you can get and then do things with it. Also, level of detail is kind of also important if you do games, something virtual reality as well. That's also a use case. You like read in the complex source file, very detailed. You generate like several level of details for certain use cases. Maybe you just want to have the bounding information and you are not interested what's inside, so you can do that as well. And here, most important thing, conceptual data mapping. That's very important, because there are concepts of objects, like some say also ontology or semantics. What's actually like a screw, or what's a hammer, or what's like a table? I can not only the 3D object, but also like I can put things on it, for example, or I can manufacture it, these kind of things. And so the conceptual data mapping is crucial. Is it actually the same thing I'm talking about when I read it in and I write it, or is it something different? In domain-driven design, you have this notion of ubiquitous ubiquitous language as well. So what does it actually mean if I talk of a table? Scene description, schema gaps, exactly. Yeah, some informations are not important for one domain, but very important for the other domain. So some information may also missing. Schemas helps enrich the interchange of our scene description and grow the exactly. So that's also right now the stage of OpenUSD in industrial use cases. We need these new schemas describing our domain objects, right? There is no like a common standard right now for a lot of objects.
So
yeah,
the standard that we have, I just gave you the link.
Yeah, it's but yeah, you need like still, yeah, there's several efforts on the way. So namespace prefix attributes, exactly. Yeah, naming the attributes is also a way of like having a convention for how to name things. Namespace prefixed attributes are the standard approach for representing. So it's like let's see that. Oh man, slow. But this is what they talk about, like Acme sensor temperature. That's kind of the whole name, but you do that like the grouping like that. All sensors of Acme and actually temperature. Yeah, and that's also what that's a good thing. The example, you do this basically before actually writing some code, right? You do first like you think about what actually do I translate and what's the different domain specific information. And you can also talk with the stakeholders to do that.
Like for instance, what I'm just doing right now, I've got a customer that has data from Cinema 4D, and he wants it to be transferred into USD. And the problem is not the mesh. The problem is the material. And I actually create a dump JSON file from all the material properties, and then I take it and then I transfer it with my own translator into an OpenPBR service. So you can do those kind of things.
Sorry, I just have to dial in again, I guess. Yeah.
Michi, you still there?
Now I'm back. Sorry. I
Okay.
think. Yeah. So. Okay. So what did you say, Jan? Your last comment was?
Okay. I just I repeat it. So I've got a customer that wants to get his Cinema 4D stuff into OpenUSD. And the problem is always the material, because the material that he is using inside Cinema 4D is not being transferred correctly because there is just no transfer. So what I made is an export plugin for Cinema 4D, which is just writing out all the properties that I have in his material, writes it into a JSON file as a dump file, and then I grab this and reconstruct an OpenPBR material out of this. So you can do those kind of things.
Yeah. And this is also something which such a document can help. And I think also NVIDIA did a good job to do like these blueprints for all these efforts. So you can take this as an example and say, okay, I've got OBJ as a reference, and see. And now we go into what's the vertex data. Ah, there is nothing in OpenUSD. What's an object? Ah, that's probably a mesh. What's and so you go attribute by attribute, basically, right? And then you have quite a good understanding how to map things. So so see for the converter, what do we want to do? It also speaks of material extents. That's right. And here is, yeah, that's also a good document in this link. Let me open that as well. There is a whole blueprint for how to map things and who to actually get involved with, and so yeah, that's really good thing. Yeah. See, conceptual mapping document and examples. So I would definitely advise to also read these informations. So yeah, now that we have found our mapping, vertex points, primrose, etc, material, okay, makes sense. Let's try and do that. So what do we do? Yes. Oh well, yeah. That, right? But I think we already, don't we have that already? Oh no, I see, we have that, right? It needs the TF again. What next? Let's add to our extract method. Underneath, we define the stage before we call return stage. And our initial loop, go through our meshes in the scene. We need to have like a valid mesh identifier. Yeah, that makes sense. Okay. Yeah, well, if you're not used to Python, it's always like the indentations are very important, because it defines the level. Okay. So let's go to extract. So we have opened our stage. So we should basically do this. See, and here when I pasted it didn't make the indentation right. So I have to, because now this should be done in the for loop, right? So I put it here, then it's okay. What does it do? It uses the mesh name and uses this method to make it a valid identifier. That means like replacing invalid characters with an underscore. Right? Oh, yeah, it says that as well. And then we create our mesh with that. First, we extract the vertex indices of the face and the number of vertices for each face from our objects. Okay. Within our loop, we'll create another loop to go through each vertex index for each mesh. This allows us to assemble both the face vertex indices and the face vertex counter arrays for our USD jump. Add the following code underneath where we defined USD mesh. Okay. So here is our mesh in the loop. We have to make sure that see, now I have again pasted it to the wrong indentation. So I selected and press top. Now I'm good, right? So we have our mesh. Go through all indices of mesh indices. Here we have an empty array, 2 empty arrays, right? And then we like put this array into this probably, yeah. And vertex counts, yeah, it counts what we got as an array from here, and it says, okay, we have like these kind of indices here. Yeah, makes sense. So we have like these kind of things, right? Okay. So now we have, yeah. See, from the data structure, it's like the faces, like our triangles, right? So we have like 2 faces here, 2 triangles, 1, 2, 0, 1, 2, and 0, 2, 3. So these guys, right? So we get 2 basically arrays from our indices now. And
But
those,
this is OBJ, yeah.
that's the OBJ, how it looks like, right? And what we do now, we just read in what we get. So this mesh, you know, is the OBJ mesh, right? Because we used the asmp library to import this OBJ file, and it gives us basically the OBJ information, right?
But it flattens it.
It reads it as it is. Probably I'm not familiar with asmp if it does transform itself, but that's kind of the description as you get it from asmp. Yeah.
Okay.
We should have looked more into the mapping document, or if you want to look into the OBJ definition.
I mean, this is just one example, and OBJ is like one of the oldest, most basic mesh.
Yeah. Very basic, but it looks like this. So we have our vertices, right? And we have the face descriptions, right? So you say F, it's an ASCII-based file format actually. And this is that's face connecting vertices, textures, and normal sets. Well, probably there are 3 indices for like the vertex, the texture, and the normal, and this is then a face. So, but yeah, I think let's stick to this representation. Basically, we have a list of vertices, and we have indices mapping these vertices to faces. Yeah. So points in USD are the same, right? And what do we have? Both solid, right? And lists of faces that reference their members' vertices by index. OBJ gives one global list of vertices for all objects, whereas OpenUSD tracks vertices on a per mesh basis. Yeah. So see, and asmp has already taken care of mapping the global vertices of OBJ to per mesh. So yeah, there is like another converter in between our converter of OBJ to USD. It's asmp, right? So yeah, we basically don't map the OBJ directly, but with what asmp gives us. But yeah, nevertheless, as an example, it's okay, let's say. So what do we do? Another difference to note is that the indices from OBJ are grouped on a per face basis, but OpenUSD prefers a flattened list of indices that can be recomposed into faces using an ordered list of face vertex counts. For an example, compare the faces and first vertex indices array of the image above. Yeah? See the difference? Here we have like one triangle, the other triangle. Here we have all the vertex indices and another vertex count with 3 and 3, which tells this, then we're good, and then the other ones.
That's what Jan called flattening.
What?
Marcus said that, not me.
Okay. Someone mentioned
Flattening, yeah, because you don't have like, you just have one flat list of values, and here you have like 2 arrays, an array with 2 arrays, basically. You know? Any questions or remarks about that? Should we go on? So yeah, basically what we just said, it flattens the per phase indices into a continuous list. For each phase, it counts how many indices made up. And it says like then 3 and 3, because we have all the same. Could be also maybe 4 or what depends. Now with the rest of information from us, we can create the attributes to define the points, phases, normals of the meshes in OpenUSD. Let's add the code to create these attributes. Place the code after the last loop, but not inside of it. Yeah, makes sense. So what do we do? Let's copy and then discuss it. See, I also did this wrong. So they said, okay, first we collect it, and then afterwards, is that for you as well, that the indentation always gets messed up when pasting? So now it's good again, right? So
My
what do
agent
we
is
do?
taking care of that.
Augmented human, awesome. Here, before we actually went into the indices, we created our USD geometry mesh, right? We said, okay, we need this USD mesh object, right? And then we collected all the vertices and the indices. And now we create like the points attribute. So the actual USD attribute containing the information we just collected, right? And always with creating attributes, that's always the same. You do like first do the create attribute, what you want to do, and then you get back the attribute object, and then you call the set method on the object. That's one thing, as you see it. It depends. Sometimes also the actual create attribute has you can go directly and give it what it should put into the attribute, like here the vertices. Yeah. Create the mesh as a polygonal mesh and not a subdivision surface. Yes, makes sense. Respect the normals or lack of normals from OBJ. So say no subdivision, and if we have more normals, also we put that into the normals attribute. And now we should basically have our mesh defined. Let's go into the. Any questions so far for this code? Good. So
Yep. Here, one question. So by
Yes.
the end of the program, the only thing the program does is saving the stage away. Nothing happens yet.
Yes, exactly. Yes. First step, just pulling in the information. But here, if you want, we actually flatten the structure to the USD attribute. So that's basically a little, yeah, just pulling in the information the USD way, I'd say. But we don't do transformation as such, I'd say. Yeah.
Okay. Thank you.
So what did they also worth noting that we're setting the attribute values in two different ways. The point attribute is set by passing default value in the create points attribute. Create points attribute. Yeah, that's basically that. Face vertex count is set by calling set using the USD attribute object returned by the create. Yeah, that's what I said before. Yeah. Both ways are available and valid. I tend to do like the set, method more. And you can also, yeah, that's a good point. If you're using set, you can also set like the value for a certain point in time. So every attribute basically has the possibility to set a value in time assign the value for a certain point in time. And this you can do with the set method. Yeah. Saying some none, so that these meshes are treated as poly meshes, not sub-T meshes. Yeah, well, we can't. Yeah, OBJ doesn't have that concept of sub-T meshes, so we won't use that. Okay, so it gets exciting, I'd say. We save it and try what happens. So that should look like that. Yeah, I think we're pretty good, right? Yeah. I copy that, right? Python data exchange. Yeah, basically we just say take that and do something with it. So I execute it. So that's what did happen? It didn't do it because we don't have async installed, right? So that was part of the setup. So I've got a new laptop here. So let's see what do we have to do. There was installing USD view and setting up Python right here in this point. And there also was information on how to set up async. See, installing async, right? Where is it? Oh, I don't know. USD core here, async. Aha. So we just need a pip install async. For those not familiar too much with Python, that's basically the method to get every dependency library you need. Like you just do pip install and then you say what you want to have. Try that, pip install. That may take a little. And here also important that we have activated our environment because this is installed now in this virtual Python environment, right? So if we don't have activated this, it gets installed in another location, right? So you want to make sure that we just have this activated. Okay, so it has basically installed that. So maybe let's retry, right? Whoop. That's more. Takes a little more. What does it do? See? Oh, did I actually save it? No, I didn't. No. Oh yeah, let's see what happens. See, okay. So what did it do? Like converting data exchange, shapes OBJ, executing extraction phase, executing transformation phase, converted results, output as blah. So let's see, I think I haven't saved this, so I'm not sure if it actually is empty. Yes, it's empty, because last time I saved it was just the basic creation code. So now let's save that, save, right? And let's do that again. Whoop. Aha. And now, oh, that looks better, huh? So we have a lot of like shapes in that, vertex indices, points, a sphere. Sphere is pretty, yeah, lots of triangles, right? Yeah, that looks like a valid file. Maybe to see first what that's the OBJ file we just converted. It looks like that. It's Blender, yeah, generated. And here you see we have an object name, the vertices, the normals, the texture coordinates, also some material. So here are the faces and lots of vertices for the sphere. Makes sense because that's a round object. Lots, normals. Yeah, it looks kind of the same, right? So maybe let's let's look how it actually turns out. Let's go back to our.
Is there actually an advantage from the way USD writes the mesh data than to OBJ? Or is it just taste?
What was the question?
If there is an advantage of how USD writes the vertices and everything, the mesh data into the file compared to OBJ, or is it just taste?
I think it's more optimized, yeah. For it's still readable, so that's good, right? But yeah, OBJ is also much older format.
Yeah.
So this way of having an array with saying this and this and this and this is with this indice count, it's more GPU optimized.
Yeah,
okay.
That's a good point. Yeah, right.
So it can grab it faster.
Yeah.
Okay, good.
This comes into play in a few months. Apple just released a new data compacting algorithm that all these floating point arrays can be quantized and gets even more compact than the GLTF. What's the name?
GLB.
Draco.
Yeah.
The Draco algorithm is using quantizing, and the new PCM algorithm does similar stuff, but is 42% better.
Is that only for Apple then, or can we as non-Apples use it as well?
It was proposed to get into the release of March.
Yeah.
2 days ago, but it didn't make it. But other important stuff made it. So
like
the
Gaussian
March
splitting
release of USD. Yeah?
Oh, I just used render to Blender to load our original file, right? The OBJ, to see how it actually looked. Don't mind the block here. It's
Kill it, please.
So that's the original file, right? So we expect, what do we expect now to see in our USD file? We didn't do anything with material yet, so we expect to see like grayish kind of objects, right? But it should look like a sphere, this cone, and this cube. I have to put some power on as well. My laptop is quite slow. So what did I do? It's still loading. Yeah. I also have to like put that back. Go. So it's still trying to load the USD view. Maybe I just have to plug my laptop in because everything is pretty slow right now. So yeah, it should look like this. Oh, now it comes. Now we go. I just have 10% left. So. Saving energy, probably.
You just have a very complicated scene, you know. It's hard to load.
Complicated. Oh, come on. Oh, no.
Michael?
Yes?
If you don't mind, please share the code file, because I think I did something wrong. I'm not able to create the entire scene, just the code. So I must be doing something wrong that I'm not able to check now.
Yeah, you can here you can click to reveal the Python code.
Okay.
So
got it.
just copy this and you're good to
Thank
go.
you. Thank you.
Yeah, okay, sure. So
Cheat sheet included.
yes. So that's what we expected. We have like the geometry, but we didn't assign any material yet, and so this is basically our current state. And with that, I'd say we're at the point. My battery is draining as fast as I can see, so good that we made it so far. Yeah, I'd say so next time we go to the material, and yeah, for now I'd say yeah, thank you and have a good weekend, right?
Thank
you
you.
very much.
Safe travel.
Thank you.
Thank you.
Thank you very much.
Bye.
Bye.
See you next
Bye.
time. Cheers. Bye-bye.
Ciao.
Michael, you should consider to buy one of those new MacBook Neos.